Good evening, Vinians. Good evening, V enthusiasts. I know all of you are pretty much nervous. Some of you are probably even depressed. Some of you are probably very hopeful for the next attempt because the JEE February results were out yesterday. And I'm not going to ask you how many marks you got or what is a percentile, because that is irrelevant now. What we should focus is on our next attempt. What we should focus is how we can make it better. If you have got 96 percentile, how to make it 99. If you have got 90 percentile, how to make it 97. If you have got even less, maybe even 60 percentile or 70 percentile or 80 percentile, we have to make it more than 90. And if you have got 98, 99, we have to see how to make it 99.9. So we have come here to improve. We have come here to learn. We have come here to become a hero from zero with me, Shreyas, your master teacher for physics at Vedantu, going live. How is everyone? How are all my minions? Hello Nancy, Neha, hello Sakti, hello Manju, Nad, hello Samla, hello Bujia, hello Yalni, hello Gayatri, Ram Neni, hello Andrew, hello Sanjit, welcome aboard, hello NVD, hello Kirito, hello Vinayak, nice to see Ankit, hello Baidu, hi Devki, hi Ravan, hi Sai, hello Kashish, hello Ritvik, hello Pranav, student J, welcome, welcome, welcome. So I'm really glad that all of you are here, and I might have missed few names, but don't worry, keep answering. Make sure that you attend this session properly, and definitely if you keep answering, irrespective of whether it is correct or wrong, if you maintain discipline, definitely I'll take your name. And this is Shreyas here, your master teacher for physics at Vedantu, and I not only teach on this very special channel, which is V Enthuse, which is dedicated for all the English medium students across the country and even beyond the borders, but also I teach on the regular paid platform of Vedantu. All right, I take all the long-term batches, I take the, even the micro courses and so many other things. And I have been teaching for quite some time now, and under my mentorship, a lot of students have cracked the JEE examination, and many of them have got 2-digit All India ranks. Now, to know more about me, to stay in touch, to follow me and get more updates about me, you can definitely ping me and also follow me on Shreyas_Vedantu, which is my Instagram handle. So do not forget to check it out. Hello, welcome Suyash. Hello Ahangar. Hello Rama. Hi Rishi. Welcome, welcome aboard. Hi Samla. Nice to see all of you out here. Hello Anand. Hello Artijo Datta. Wow, Asmi is also here. Hi Priya. Welcome, good evening, good evening. And before we begin, do not forget to smash that like button out there, and do not forget to hit the subscribe button if you're new to this channel. Because this membership is free, you can hit the subscribe button for free of course, and you get all the regular updates and you'll get all the important sessions, yes, at your doorstep, sitting at your home by all the amazing teachers out here. And this is very special dedicated channel for all the competitive exam aspirants of 11th, 12th standard, including the droppers. Nice to see all of you. Hi Ansab, welcome, welcome. Yes, is this series for all the chapters? Yes, this is a zero to hero series for all the chapters. But before the March attempt, I'm going to cover only some chapters which are very, very important. So even before this, I have conducted 0 to hero for collisions, 0 to hero for center of mass, also 0 to hero for rotation and all that. So semiconductors was done, collisions, rotation. Then today is electrostatics and gravitation. Tomorrow is magnetism and EMI. And there is going to be a run-up before the March attempt, and after the March attempt you're going to have the remaining chapters like fluids, elasticity, current electricity and modern physics, and other chapters like that will also be covered. NLM, friction, circular motion will also be covered from 0 to hero series for the April attempt. So do not worry. In case you have missed any of these classes, guys, do not worry, you can always watch them because all the live lectures also get recorded. But remember, it's always fun to watch live because look at the crowd out here, look at the environment, look at the competitive spirit, and obviously I will also take your name and you can make new friends when you're live. And also, it's always fun to learn live than watch it recorded. But there is an option always to watch any of the sessions or lectures in a recorded format in case you miss it. Hello, good evening everyone. Hi Vishwa, hi Sujal. Well, you're not so much late. Hello Aishwarya, nice to see all of you. Yes, with problems as well. And guys, all the PDFs, all the problems, all the important notes, all the updates are there in our Telegram group. So do not forget to join our Telegram group. The link for it is there in the description box below. So do not forget to check it out. So let's begin. Yes, Vikram, hello, good evening. Lots of fire out there. Hello, Satyapriya, welcome. Yes, Master Blaster Rajshekhar Murthy is back. Hello, Venu, you two are back. Good to see you. Nice to see. Yes, let's begin with our first set of formulas. I'm going to tell you all the important formulas of this chapter, and then we'll see how to apply them in this Zero to Hero series. So first, make sure that you note them down. Although you are going to get the PDF in the Telegram group as well as the description box, but for practice sake, please write it down. Also, take a screenshot if you feel like referring to these formulas during the session. Okay, now Coulomb's law everybody knows. Force between two charges is 1 upon 4 pi epsilon naught, where epsilon naught is permittivity, Q1 Q2 by r square, and this r hat is a unit vector in the direction of the two charges. All right, it's a unit vector along the line joining the two charges. So Q1 Q2 by r square. This is not so important because everybody knows what direction the forces are. If they are like, then it is repelling. If it is unlike, then it is attractive. Field due to a point charge is 1 upon 4 pi epsilon naught q by r square. Now you should also know the dimensions of field, because field is nothing but the force per unit charge. All right, so hence it will be always newtons per coulomb. So that's how field is defined, the force acting per unit charge. All right, yes. Now next thing, electrostatic energy. So the electrostatic energy between two charges, well, there should be a plus over here. All right, so it cannot be minus. Well, the plus or minus automatically comes based on the charges. So electrical energy between two charges is 1 upon 4 pi epsilon naught q1 q2 by r. Now if one of them is negative, then the energy is also negative. But if both are negative or both are positive, then the energy is also positive. Obviously this energy is in joules. So it's basically the energy between two charges. What is the energy stored between two charges? For example, if I have two, let's say this is a positive charge here, another positive charge here. If I leave them, I know they will repel and they will move away. How will they get the kinetic energy? They will get the kinetic energy because there was some electrical energy stored between those charges. And that formula is given by this. Okay, plain and simple. Now, the energy which is stored per unit charge is called as potential. So there is a very small difference between U and V. U is the actual energy, but V is the ability. It's how much energy can be there per unit charge around a charge. So this V is just like field. How is field? Field is force per unit charge. So this is also very similar. This is nothing but the energy per unit charge for a body, and that is why the unit will be joules per coulomb. Keep this in mind. So 1 upon 4 pi epsilon naught q by r, and these are standard formulas which you should know. E is minus dv by dr. This is something which is very standard. So field is negative rate of dv by dr. This is standard, you should know this. And if you take dr on the other side and if you integrate it, so you will get integral of dv is, you know, E dot dr with a negative sign. So remember this, actually E is minus dv by dr. You can automatically shift dr and integrate both sides if needed to find out potential. Keep this in mind. All right, so do not worry. Okay, no problem, Shobit. I've just started 5 minutes back. You can always replay back a little bit. Well, Satyapriya, I already had my coffee, so I don't need it. So yes, it's kind of a potential gradient. The potential gradient is the field, the negative of that. All right. Good evening, Pranav. Join in. So, sir, in which cases do we put the value of the charges along with their sign? So, Arjito Datta, you don't have to worry about the signs of the charges for forces and for field, because for forces and field, right, the direction is already understood. We know where the field or the force will be. Only in case of energy, always make sure that you put the values of the charges along with the sign. So that's the rule of thumb generally. All right. So I hope I have answered that question. Okay. So keep all of these things in mind. Very, very important. And at this point of time, let me also tell you one more important thing, that in case you want, oops, 1 second. Okay. In case you want in detail lectures, just 1 second. Okay. I think something is wrong today with my screen, but okay, let's see. Okay. Yeah. So if you want in detail lectures, then let me tell you where they are available. Okay, I'm not sure why my touch is not working today. Hold on, guys. Okay, I'm not sure why my touch is not working today. Well, this is interesting. Okay, this works. Okay, just 1 second, guys. Glad it's working. Okay, so in case you have missed any of the classes, then you can just go to VNthew's playlist. Okay, so once you go to playlist, then if you just go to the physics part, all right, so if you just click on the physics part over here, right, so over here I have created playlist for each and every chapter. So like you can see over here, all right, so there is a separate playlist for electrostatics and gravitation. There are 7 lectures. I'll repeat it. There are 7 lectures separately for electrostatics and gravitation in detail. So if you feel like revising this chapter in detail, complete A to Z about it, let's say you have some missing part, you want to know about it, so everything is there in detail, like potential, one lecture is just for Gauss law, one lecture is for satellites, one lecture is only for dipoles and dielectrics, one lecture, again a sprint session and all that. So all of this is there in this playlist, so you can always watch that. But remember, today's lecture I'm going to make you revise the formulas, and we are also going to see the application of it. All right, very good, Shubhanshu Bhumik. Glad you have taken the right decision. Yes, next important set of formulas. Electrical dipole moment is charge into the distance between the dipoles, and remember, the dipole moment is a vector quantity, always goes from negative to the positive charge. Look at it, always goes from negative to the positive charge. Because of a dipole, the potential, so because of a dipole, the potential anywhere around it is given by 1/4 pi epsilon naught P cos theta by R. P is the dipole moment, R is the distance from the dipole. The distance from the dipole. So this is the potential due to a dipole. All right, keep this in mind. So Arbaz, so like I said, it depends. For March attempt, this lecture is useful, but if you are preparing for April attempt, then definitely you can watch all the playlists. All right, so that will be helping you out there. All right, excellent. Next, field because of a dipole. So around a dipole there will be an electric field. Remember, that field has, yes, 2 components. One is the field along the axis, well, along the distance, that is ER, that is given by this formula, and the field which is perpendicular, that is called E theta. So these are the 2 values which you are supposed to remember. 1/4 pi epsilon naught 2 P cos theta by R cube, and 1/4 pi epsilon naught P sin theta by R cube. Keep this in mind. All right, I hope this is clear. Every minion understanding it? I'm guessing you guys are busy writing it. Okay, the torque on a dipole which is kept in somebody else's field is P cross E, standard, and the potential energy of a dipole placed in somebody else's field is minus P dot product with electric field. Very good. Yes, Ankit making notes. Yes, permittivity will be there in every formula of electrostatics, but in magnetism you will have permeability, and in gravitation you will have G. So in gravitation you do not have permeability or permittivity. Very good, very good. Yes. Is there any formula for field at any point in a dipole? Laksh, exactly this is the formula, ER and E theta. So what is ER and E theta? I'll repeat. ER, this ER is nothing but, see, this is the dipole, right? This is the dipole. So you are at some distance R. So along that R, that component is called ER, and perpendicular to that is called E theta. So there will be 2 components of the total electric field. One is ER and another one is E theta. So those 2 components are given by these values. I hope this is clear. Okay, very good, Sujal, very good, excellente. Come on, Sheikh. Semiconductors से problem है sir. Acha, so semiconductors has already been done in 0 to hero series, bacha. So just watch the recorded lectures which I have already done just few days back. Okay, cool. Torque formula is only for external fields. Datta, well, it is only for external uniform fields. Remember that. Only if the field is uniform, you can use these formulas. Okay, cool. Yes. Umarani, I think you should check your internet connection because the video is fine only. Maybe check your playback settings or your video settings. Make sure it is on high definition out there. Yes, Bhavani, this will be enough for March attempt. Okay, next, electric flux is nothing but electric field dot area vector. So integration of that will give you the flux. E dot dA or ds is the flux, and Gauss law says that the net flux is enclosed charge by epsilon naught. Very important. So what if you have multiple charges over here, and if you take a random Gaussian surface, all right, so there are some charges inside. So these are the charges inside. There could be positive, negative, doesn't matter. All right, so there will be some field lines going in, out, doesn't matter. So the electric field dot the area vector at every point gives you the total enclosed charge by permittivity of free space. Keep this in mind. All right, come on minions. Yes, let's go ahead. Okay, next up, field due to a uniformly charged ring on its axis is given by 1 upon 4 pi epsilon naught radius of the ring square plus distance from the center square whole raised to 3 by 2. That's the field due to a charged ring on its axis. Keep this in mind. Hello Shibi, join in. Welcome. No, I am not in Chennai. Satyapriya, I am right now in Bangalore. Yes, Venu, I am doing this chapter because these are high frequency chapters, very important chapters. So focus on the session. We had conducted a roundtable conference where we discussed all the important chapters, all the high frequency chapters. So that's why we are doing these chapters first. And then after the March attempt, I'll be doing the other important chapters. So first I want to get done with the very important chapters before the March attempt. Hello Arjun, hello Mayank, welcome. Chakri, focus on the session. Okay, electric field and potential due to a uniformly charged sphere, very important formulas. Also the graphs. When you are having a uniformly charged sphere and you are inside, r less than r means you are inside. It is this. QR by r cube. Small r is a variable, capital R is the radius of the sphere. But when you are outside, that sphere behaves like a point charge. Keep this in mind. Okay, so when you are outside, that sphere becomes like a point charge. And potential formula also you should know, very important. So this is for inside and this is for outside. You can see for outside, it's just like a point charge, nothing different. Thank you, Sujit. Welcome, Abhiraj. Join in out here. Yes, Laksh, hold on. So I hope you guys are making notes. All these are very important formulas, and all the new members, all the new timers, all the new students, do not forget to hit the subscribe button and the like button so that YouTube will recommend you this channel again and you do not miss out on any important updates, because next week we are going to discuss on this channel all the papers of the March attempt as well immediately. If you write the paper in the morning, in the afternoon we are going to discuss the morning attempt, and the afternoon attempt will be discussed in the evening. So all these discussions are going to happen in English, because this is an English channel and we have made this channel for all the English medium students out here in this country and beyond the borders. So do not forget to hit the subscribe button out there. Okay, next up is again due to a shell. For a shell inside and outside, what is the field? For a shell inside and outside, what is the potential? Very important formulas and graphs. For a line charge, meaning this is nothing but lambda is nothing but this lambda is coulomb per meter. If you have a line charge, a charge which is there on a line, the field due to that line charge is given by this particular formula. All right, lambda by 2 pi epsilon naught r. Similarly, field due to an infinite sheet. So you have a sheet which is charged, all right, with sigma as the charge density. This sigma is the coulomb per meter square. How much charge is there per meter square? Then the field which will be going both ways is sigma by 2 epsilon naught. but due to a conducting surface, it is sigma by epsilon naught. Notice the 2 not being present over here. Please understand, this field due to an infinite sheet, meaning, alright, this is a sheet like this. So the field, because of that, alright, will be both ways. Alright, so it will get divided by 2. Alright, it is getting divided by 2 because it is going both ways. But when you have a conducting surface, alright, so the charges are only going to be there on the periphery. Keep this in mind. The charges will be only there in the periphery, and the field will be coming out of the conductor like this. So the field just outside the conductor is given by sigma by epsilon naught. Keep this in mind. Okay? Yes, keep this in mind. All right. Linear charge density is lambda. What is vicinity? Vicinity means very close to the conductor. If you go very far, then this formula is no longer applicable. Yes. So Laksh, yes, charge can be induced in conductors. In fact, you can also have polarization in insulators. Keep this in mind. Yes. Having two-way divisions. Yes, Ruby. That's why divided by 2. Okay. Keep this in mind. All right. Great. SI units, Bhavani, of what exactly? All right. SI units of what? These are all SI units, by the way. Yes. Okay. Very good. Hello, Basanti Thakur. Good. You joined in. Great. Hello, Neha. Glad you're here. Okay. So I hope you have made notes of this slide as well. Going ahead to the next slide. Here it comes, gravitational energy and gravitational forces. So gravitational force, just like before, it is minus gm1 m2 by r square. Don't worry about this minus sign. This minus sign just stands for it being attractive. Alright, so if two particles are separated by distance r, so the force is always opposite to the separation between them. So it is always inwards. So other than that, you always know what is the direction. So don't worry about the minus sign. Gravitational constant, you should know. And the escape velocity on the surface of any planet, root 2 gr. Something which you should again know. Gravitational energy associated with two particles is minus gm1 m2 by r. So there should be a minus sign out here. Alright, there should be a minus sign out here. Keep this in mind. Alright, so minus gm1 m2 by r. So keep this in mind. It is always negative. It will never be positive. Keep this in mind. Hello, Spirit MO. Welcome. Join in. Hi, Ritika fam. Welcome to the session. So all the new members, do not forget to subscribe to the channel so that you do not miss anything. All right, very good minions. All right, yes, let's do this. Yes, we are going to do concepts as well as previous year questions as well as problem solving now. So problem solving is going to start in a bit, just 2-3 more minutes, and we are going to start with problems. So first, I'm making you revise all the formulas so that this is there in handy. You can take screenshots. You can also download the PDF after the session is over from our Telegram group. All right, very good. So Devki, don't worry, bacha. Forget about the results. Let's focus on March and April attempt, because these series are meant to make you a hero irrespective of what your score was. So do not worry. Okay, let's do this. Okay. So at the surface, the acceleration due to gravity, all right, is equal to, at the surface, it is gm by r square, which is 9.8 meters per second square, which you can also approximate it as pi square. So pi square is almost 9.8 approximately. So gm by r square standard for any planet. At a height h, use this formula. So it is actually g divided by, you can see this is raised to minus 2. Alright, so actually if you bring it down, it is below. So g divided by 1 plus h by r whole square. But if height is very small, using binomial approximation, you get this as the final result. Okay, yes, you will be blocked for spamming. So make sure you do not spam. Yeah, do not spam out there. Alright, yes. Okay, cool. Yes, so at depth d below the surface, it is 1 minus d by r. Notice there is 2 in height, but there is no 2 in depth. Okay, cool. Is that clear? Welcome. All right, let's get going to the next one. I hope you have made notes. All the minions say, yo, if you're writing notes, if you're making notes, if you're taking screenshots, if you're practicing along with me. Come on, minions, let me know in the chat box if you are writing these things down. I hope it is a good revision for all of you out there. Very good, very good, very good. Yes. So Kata, for in-depth explanation of all these things, please visit the playlist like I just mentioned some time back. Please make sure that you visit the playlist for in detail studies of any particular topic. I have made playlists for each and every topic what you can think of for JEE. All right, cool. Yes, Suma Anjali, why not beta? If you got 93, like I said at the start of the lecture, you can definitely get 98. Yes, make sure that you practice as much as you can, attend these sessions, and if possible, join the crash course so that you can get your full push. You can practice mock tests, you can get all your doubts resolved as well. Now, next thing, Kepler's laws, just make sure you write it down properly. Make sure you have a glance at all of them. Law of orbits, all the planets move in elliptical orbits. Sun will be at the foci. Law of areas, the line that joins the planet to the sun sweeps equal areas in equal time intervals. And law of periods, T square by R cube is constant. And in the second law, another important formula, dA by dt, which is also called as the aerial velocity. Aerial velocity. These questions came in the previous JEE mains many times, and that is nothing but L by 2m. What is L? L is angular momentum. What is m? Mass of the planet. Okay, so it's the mass of the planet. So angular momentum by 2m, and this dA by dt, this is nothing but going to be a constant. Keep this in mind. Very, very important stuff. Every law is important, Sakti, in fact. Okay, yes, yes. Laksh, don't worry about that, but I'm pretty sure you're getting a hang of it. All right. No, Jyotsna, it's not buffering. Just check your internet connection. Just check your settings. I'm pretty sure nothing is wrong on my side. All right. All right. Sarah, these are 0 to hero one-shot marathon sessions. Like I said before, if you want in detail, I'm not teaching over here. First of all, let me tell you, I am making you revise things. I'll be starting problem discussions now. So if you do not know these topics, my advice is two things. Either you watch all the lectures in the playlist, or number two, please join the crash course. All right, cool. Let's get going. Let's get going to the next one. I hope you have made a note of this or taken a screenshot out there. Come on, minions, let's do this. Okay. So before we begin with the problems, do not forget, we are also aiming at Eklavya batch, which is the one-stop solution for the JEE Advanced preparation with all the best master teachers out there. And these Eklavya batches will have a lot of sessions from problem solving to test discussion and doubt solving, and a lot of assignments will be provided. In fact, we had more than 500 selections last year from these programs who got more than 500 students got into IITs just from Vedantu alone. All right, just through these programs. So this is something which is very important, and the batches are going to start on 8th March, 19th March, 1st May and 29th May. So these are your entry points, and if you have got 96 percentile and above, then you will be getting, you can at least fill the link which is there in the description box, and you will get the call for joining this batch. All right, and if you have got lower, then let's make sure that we get really good percentiles so that you can start preparing for JEE Advanced. And remember, these batches are for free of cost right from the start till the end. So free of cost batches, Eklavya batches. Keep this in mind. Shall we begin now? Here is your first question up on your screen. Okay, so Laksh, concentrate, binary stars, everything, etc. will come. Don't worry. Let's concentrate now. Yes, come on, come on, come on. Ashirwad. Guys, if you just have any doubts, do not forget, you can write your comment after the video ends below this video. Below this video, you can write your comments, not in the live chat box. I respond to all the comments that you post below the video. So do not forget, you can ask me whatever doubts you have below the video after the video ends, after the session ends. Focus on the session right now. Okay, Ashirwad? Cool, cool, cool. Hello, Yashi Singh, welcome. Join in. Make sure, guys, you don't spam. Yes, yes, let's begin, let's begin. Okay. Kata, you're free to go there. Nobody has asked you to come over here. Please go wherever you want. Nobody is asking you to stay here. Okay. Okay. So let's see how many of you are going to get this question. A lot of you are saying A. Some of you are also saying D. Well. Capacitance completed or not? Manjunath, this is not capacitors, this is electrostatics, Gauss law and gravitation. Okay, so many of you are saying A, some of you saying D, very few people also saying B or C. Well, let's see how to do this. Well guys, first of all understand, when you have a liquid between the two plates, or don't worry whether it's a capacitor or not a capacitor, everybody knows that capacitor means one side will be charged with one sign, other side will be charged with another sign, correct? So what will happen is, in this liquid, that liquid will have induced charges. It will have induced charges. So what will happen is that, guys, you are going to see opposite to the positive, you will have negative charges, and these negative charges will get pulled upwards like this because of the positive charges of the plate. So there will be induced charges inside that liquid, and that charges are always opposite, so there will be attractive force, and that's why the liquid will get pulled up. That means the answer should be rises. Is that clear? Is that clear? Very good, very good. I hope this is clear. All right, I hope this is clear. I hope this is clear. Everyone understanding this? I hope this is clear. Everyone understanding this? Very good. Okay, very good. Chalo, let's get going to the next one. Option A is correct. Yes, very good, minions. Here is the next question up on your screen, and let's see how many of you are going to get it. Yes, let's do this. Let's do this. Aniket, there is a question over here. I mean, you can see that very clearly. So Rishikesh, I'll repeat again for the previous one. What happens is that when you have a capacitor, all right, when a capacitor is charged, what will happen? There is a positive charge somewhere, there is a negative charge somewhere, correct? And if you pour some liquid, there will be induced charges. The charges get induced inside the liquid, and the charges which are induced are always opposite to the charges on the nearer side. So if there is a positive charge on the capacitor, negative charge will get induced on the liquid, and if there is negative charge, positive will be induced. So what will happen? Unlike charges will attract, so the level of the water will rise. I hope that makes sense. Okay. So what will happen, basically, Aniket, that was understood, what will happen to the liquid level, whether it will rise or bhavna. Try to understand the bhavna. Okay, a lot of you are saying D out there. Okay, so well, there is a very simple way to crack these kind of questions, and I'll tell you what is the logic behind it. See guys, I just told you the electric field, all right, the electric field near the surface, all right, the electric field near the surface, let's say this is E1, this is E2, is given by sigma by epsilon naught, correct? I just told you that, near the conducting surface. Now let me tell you, if these two surfaces have some radii, R1 and R2, then for a conducting surface, the charge density is inversely proportional to the radius of curvature. Very, very important. This is based on the fact that at sharp ends, the field, all right, the field is strong. Keep this in mind. At sharp ends, when radius of curvature is small, when the radius of curvature is very small, so if you have a conducting surface like this and there is a blunt surface, so this is a sharp edge, their charge density is more. All right, where there is a blunt edge, the charge density is going to be less. I hope this is clear. Okay, very good. So guys, understand that eventually what is going to happen, electric field is going to be inversely proportional to the radius of curvature. Keep this in mind. Keep this in mind. This is very important formula for your rescue, and therefore you will see E1 by E2 is going to be R2 by R1, and R2 by R1, that means it will be B divided by A, and that should be option C. Is that clear? Is that clear? I hope this is very, very clear. Hooke's law, Ruby, this is not exactly Hooke's law. All right. So this is basically the charge density for different curvatures of a conductor. This is something which is standard. You should know that. Okay. Clear? So Bhavani, this is a standard formula. Charge density for a conductor. You should know this. So at a sharp edge, the charge density is more. At a blunt edge, the charge density is less. And electric field is sigma by epsilon naught. That means electric field will be inversely proportional to R. So E1 by E2 will be R2 by R1. As simple as that. Alright, let's get going ahead. Very, very simple. Okay, let's get going. Everybody should be understanding this. So guys, I'm repeating once again. If you have zero idea of this chapter, then these sessions will be of no use. You should have some idea of the chapter. You should have some basic understanding of the chapter. It should not be like, sir, I'm seeing electrostatics. What is sigma for the first time? Obviously, if you're going to say that, sir, what is sigma? Sir, what is this field near a conductor? What is this? Obviously, then understand, for that you have two options. One option is you have to visit the playlist. Second option is you can join the crash course so that you can revise all the topics right from the scratch. Keep this in mind. All right, come on, let's get going ahead. Yes, and that's the answer, B by A, like I just told you. No, Jyotsna, E is not inversely proportional to R square. A lot of people get this wrong. Please understand. See, E is not inversely proportional to R square. That is wrong. Electric field on a sphere, all right, is inversely proportional to R. Keep this in mind. A lot of people get this wrong. Understand this. E is inversely proportional to R, not R square. And there is a very simple reason for that. See guys, if you have, this is R1, if this is R2, if this is Q1, this is Q2. I hope you understand the potentials will be equal. V1 will be equal to V2. V1 will be equal to V2. If V1 is equal to V2, that means K Q1 by R1 will be K Q2 by R2. Correct? That means Q1 by R1 is equal to Q2 by R2. Correct? Now, next up, what will be E1 by E2? E1 by E2 will be K Q1 by R1 square by K Q2 by R2 square. Now when you divide this, KK will go out and you will have Q1, all right, by what do you say, Q2, all right, and you will have R2 square by R1 square. Now what is Q1 by Q2? From here only you can see that. What is Q1 by Q2? Think about it. What is Q1 by Q2? Isn't it nothing but R1 by R2? Isn't it R1 by R2? So just put, instead of Q1 by Q2, just put it as R1 by R2 into R2 square by R1 square. So you will see one of those things get cancelled out and you will see E1 by E2 is nothing but R2 by R1. You can see that. You can see that. Initial formula has square, inversely proportional, but do not forget the charges are also different. That's why it comes out inversely proportional to R. Keep this in mind. It inversely comes out to be proportional to R when you actually put the ratio of the charges as well. I hope this is clear. I hope this is clear. So the potentials are equal when you connect two conductors. This is a standard thing which you should know. When two conductors are connected, their potentials become equal. Potential of this sphere is standard KQ by R. Potential of this sphere is KQ by R. From this analysis, I got Q1 by Q2 as R1 by R2. Similarly, field is nothing but KQ by R square. That's standard. So just do the math and you'll get it inversely proportional to R. I hope this is clear. Understood? Understood everyone? Excellent Avenue. Very good. Very good. Very good. Excellent. So understand, a lot of people have a lot of misconceptions. That's why you guys are here. Very good. You guys are asking very good doubts, and ask those doubts, because only when you ask doubts, it will get cleared. Please understand, I might not be able to clear as many doubts as you are asking, but I'll try to clear as much as possible from my end. And if any doubt remains unanswered, don't be disappointed. You can always put it up in the comment section after the video ends. All right? So don't worry about it. Let's get going to the next one. Okay, let's get going. Here is the next question. Consider the situation shown in the figure. There are two plates. Forget that it is a capacitor. Just think there are two conducting plates. One is charged positively, other is charged negatively. It is connected to another two plates, but the switch is open right now. So the question is, how will the charge on this set of plates change when the switch is closed? How will the charge change? Come on, what will be the charge on that capacitor when the switch is closed? Come on. Hello Bhagya, welcome, join into the session. Come on minions, let's see. Good evening Jitendra, Akash says B. Come on, come on, come on. Sakti says Q by 2. Venu says 0. Ruby says B. Subbu Venkat says B. Venu says A. Malvika, welcome. Join in. Hello, Chandramoli says B. Fani Kumar says B. Okay, let's see, guys, what the correct answer should be. Okay, so, well, I'll tell you what. Guys, this is positive, this is negative, right? Both of them are going to attract each other. They will pull each other. They will not like to leave each other. Positive will pull the negative. The negative will also pull the positive. Now think about it. When you close the switch, why would this charge go there? Why will this positive charge leave this negative charge and allow it to go there? There is no reason for it to go. There is no reason for it to travel there, because if it leaves there, that's it. It's going against the law of attraction. They are attracting each other. So guys, even when you close the switch, nothing will change in this. In fact, it will stay as it is. This capacitor will remain uncharged, and that's why the correct answer should be 0. And that's the correct answer. Understood? Understood? Very good. So guys, make sure that you report the viruses out here so that we can keep our chat box clean. Looks like a lot of yes. Okay, cool. Okay, 1 second. Cool. Great. Okay, so electric field is inversely proportional to R square when you use Q as a constant, Yash Gupta, but inversely proportional to R when we use sigma. Yes, that is provided Q is constant, Yash, but we know that on two conductors which are connected, Q is not the same, so that's why it comes out to be inversely proportional to R. Very good, Venu, correct answer. Yes. Let's get going to the next one. And here is the next question up on your screen. Which of the following figures shows the correct equipotential surfaces of a system of two positive charges? Which of the following figures shows the correct equipotential surfaces of a system of two positive charges? Come on, minions, let's see. Let's see how many of you are going to get it. Two positive charges. Yes, Shibi, they are like charges, correct. ABCD says B, Utkar says B, Manuji said C, Rohit says D. Okay, interesting. Tech Learn, this is an English channel, so that's why we are going to teach in English. We have a special Hindi channel as well of Vedantu, which is called just Vedantu J. You are free to definitely go check it out if you want to learn in Hindi. Well, I'll tell you what, guys. See, due to two positive charges, the field lines, all right, the field lines look like this. This is how electric field lines look like. This is very, very interesting. It is the electric field lines. This is how they look like. Okay. So how will the equipotential lines look like? Remember, equipotential lines are always perpendicular to field lines. They are always perpendicular to field lines. So which of the following diagrams look as if they are perpendicular to the field lines over here? You can see that the equipotential lines are like this. Then over here it becomes like this. Okay, and here it is perpendicular like this. I feel this diagram is very much similar to this diagram, option C. So yes, lot of you got it wrong. Very few people got it correct. Yes, Abhishek Singh, correcto. Jayant, very good. Hello Prachi, welcome, join in. Yes, this is the correct answer, option C. Understood, minions? Understood? Yes, Ravan, very nice pun out there. Alrighty, let's get going to the next one. Very good, Priyal. Excellente, minions. So I hope all your concepts are slowly getting cleared. See guys, it's no use if I just tell a theory at this point of time. It's very important that you listen in to the explanation of the problem in detail, even if you have decent idea of the topic. It's okay, you might not have complete idea. That's why you are here, to get a complete picture. Through these problems, I'm going to touch upon almost each and every concept of electrostatics, Gauss law and gravitation. So guys, attend each and every question in detail. Trust me, by the end of today's class, you will feel like a hero. Alright, let's get going. There is no point just telling you, oh, this is force, this is energy, this is Kepler's laws, this is that. Okay, by heart all these formulas. No use, it's not fun. You will sleep. Okay, next question up here on your screen. A, B, C are 3 points in uniform field. The electric potential is, come on, where do you think it is at maximum or minimum? Come on minions, let's do this. How many of you are going to get this answer? Let's see. Yes, Abhishek, I'm right, glad. Very good. So Ashish, you are a little bit late, but it's okay, you just missed couple of questions, but don't worry. You can watch the other parts live out there. All right, Shruti says C, Basanti says A, Abhishek says C, Neha says something else. Oh my god, the chats are scrolling up. Well guys, I'll tell you what, remember this rule that field always goes from high potential, okay, to low potential. This is how field lines travel. High potential to low potential. Now, you might feel that the potential is same everywhere. Please understand that is something else. The field strength, field is stronger where the density of the lines is more. But here the question is not about field strength, the question is about potential. So where is the potential going to be higher? Just check the direction of the field. Field is going from here to here. So this must be higher potential, this must be lower potential. So B is at a higher potential, so hence this will be highest. In fact, A will have the least potential, so that's how it is. A lot of people would have thought about this because the field lines are uniform. So guys, field lines are uniform means the field strength is same, but potential is not same. Potential will keep on decreasing along the direction of the field. I hope this is clear. Yes, very good. Karthik, you answered first. Kya baat hai? Hooray, correcto, Manvi, right? Very good. Interesting question. Yes, Abhishek, excellent. Yes, in the direction of the field, electric potential decreases. And guys, I'm so glad that you're typing out whatever I'm saying also. In a way, it makes those things get embedded inside your head. The more you are writing, the more you are typing, these things, I'm pretty sure you will not forget, because it takes a lot of guts to type anything out here on the chat box, or also to make notes. So when you make notes or when you type something, I'm pretty sure it's all getting inside your head, and I'm pretty sure many of these questions are actually going to come in the JEE examination, because my experience is whatever questions I conducted in January or in February just before the exams, many of the questions got repeated in the Feb attempt. I am sure that many of these questions are also going to get repeated in the March attempt and even in the April attempt. So if you are one of these students, guys, you should listen to each and every question carefully. You never know what is going to be repeated. All right, let's go to the next one. When you move from A to B along a field line, all right, this is a field line, this is a field line, this is a field line. The work done by field on an electron is this many joules. If phi1 and phi2 are equipotential surfaces, in case you cannot see it very clearly, I will write it down over here. So this is nothing but phi1 and this is nothing but phi2. All right, then the potential difference between C and A is, this is A, this is B, this is C, and this is E. Come on guys, what is the potential difference? These are the 4 options out here. Let's see how many of you are going to get it. Come on minions. Simran, you can do one thing, you just replay back that part, because on YouTube you have that functionality of replaying that same part even during a live class, so please do that. Okay. Abhiram says in previous question, if it was an AC source, will B be charged? In the previous question, it's not about AC source, bacha, it's about just an electric field. So it's got nothing to do with AC sources. All right, a lot of you are saying B or C. All right, Ritvik is not getting, don't worry, we are going to solve this question out here in a bit. Come on minions. Come on minions. There should be no charge from a DC cell in the previous question. I'm not sure what you're saying, Sakti. I'll just come to the previous question in a bit. Hold on. Well, I'll tell you what is the answer for this. Well, in the previous question, see guys, oops, yeah, this is not about AC or DC. These are just field lines coming out from some charges. So it's got nothing to do with a cell, battery or AC. So don't worry about it. All right. So there is nothing in this. Okay. Well, I'll tell you how to solve this particular question. Oops, the answer is out, by the way. Okay. So I'll tell you how to solve this. Forget this. Now I know B is the answer, but anyways, there is a simple trick for this. The question says the work done by the electric field. Now the work done by conservative forces is negative of the change in potential energy. This is a standard principle from work power energy of 11th standard. So if you have forgotten this, please revise back that theory. But now I'm telling this to you. And what is delta U? Delta U is charge into potential difference. Remember, potential was energy per charge. So charge into potential will give you energy. So keep this in mind. Now it's very simple. Work done by that conservative force, all right, is 6.4 into 10 to the power minus 19 is equal to, now what do? Put the charge of the electron, because this is an electron. So the charge of the electron is minus 1.6 into 10 to the power minus 19, and that is into delta V. Minus will become plus, and you can see very clearly over here that 10 to the power minus 19, 10 to the power minus 19 goes, and 1.6 and 6.4 goes 4 times. So hence I will get delta V is equal to 4 volts. But there are two options here, -4 and +4. So I need to be careful. So remember, delta V is final minus initial. So where are you going? From A to B. So final is B and initial is A. So VB minus VA is 4. But do not forget, B and E and C are on the same potential line, equipotential line. So potential of B and potential of C is same. So that's why it is 4 and not -4. I hope you understood the steps. I hope you understood the steps. Yes, very, very important. Now I'll repeat. See guys, first of all, you should know this particular property. You should know this particular property. This is from 11th standard. Work done is negative of change of delta U. That is standard. You would have learned this in 11th standard. And in case you have forgotten and you want to know more about it, again, please check my playlist of work, power, energy. It's very important. Next up, the another important thing that you should do is use this formula. Delta U is nothing but Q delta V. That's it. Use these two formulas and you will get the answer. And the only thing that we used for equipotential lines is that potential of B and C are same, because B and C are on the same potential line. That's it. That's all we have done. All right. Yes. Let's go ahead with the next question. I hope you enjoyed this question, and a lot of people would have got confused between A and B. Next question up on your screen is this. Yes. So negative charge of an electron is also very important. Preksha, why not C for the previous one? Because A and B were on different potential lines, so there has to be different potentials. Remember, B and C were at the same potential, so the difference for B and C will be same, but for B and A, they were on two different lines, so there has to be a potential difference. All right, very good, very good. Let's get going. So what if C is on another potential line, Jayant? Then that needs to be, some other information will be given, Surya. Don't worry about it. Sorry, Jayant. Yeah, so some other information will be given. Okay, cool. Let's see how many of you are going to get this. What will be work done by external force? Yes, work done by external force is exactly negative of the work done by the conservative force. Keep this in mind. Cool. All right, a lot of you are getting this. No, Karthik, I'm not a Tamilian. Come on, focus on the session, Karthik. Well. I'll tell you what you have to do. Remember, the potential is changing from here to here to here. Correct? From here to here to here. And you can see it is becoming higher. That means the electric field must be from high to the low potential, and that must be here. that is very obvious. Isn't it obvious? Electric field must be from high to low potential and it should be always perpendicular to the equipotential line. Now, check this out. If this angle is 30 degrees, then if this is 30, this is 60, this is 30, all right, this is also 30. So this is 90. So 90 plus 30 is how much? 120. So the electric field makes an angle of 120 degrees with the x-axis. Okay, it makes 120 degrees with the x-axis. So now there are two options only, either this or this. I hope this is clear. Either this or this. Now, remember I just told you electric field, the magnitude of it is delta V by delta R. I just told you. Electric field is potential gradient, rate of change of potential with respect to distance. That's it. Use this fact and you will get the answer. Now, delta V, if I go from here to here, how much is my potential changing by? From 20 volts to 10 volts. How much is my potential changing by? Isn't it changing by 10 volts? Isn't it changing by 10 volts? And how much distance am I traveling? Well, you can figure that out, guys. This is your delta R. This is your delta R. And you can easily figure it out because if you look at it this way, all right, there is a small triangle which is formed. This is delta R. Can you figure out what is delta R? This is hypotenuse. This is a right angle triangle. This is hypotenuse. Delta R is opposite 30 degrees. So guys, I hope you see this distance is nothing but 10 centimeter. So delta R will be 10 sine 30, that is 5 centimeter. Correct? It is 10, yes, 10 sine 30. This is hypotenuse, this is 90 degree. It's opposite 30 degrees. So that means 5 centimeters, which is 5 into 10 to the power minus 2 meters. So this is going to be 2 into 10 to the power 2 volts per meter. And that is the answer. Yes, so that is 200. I hope that's clear. Very good Sanjay, very good Priyal, very good Utkarsh, very good Yalini, excellente, very good Abhishek, very good Kanu, very good Abhiram, excellent, very good, very good, very good. Anna, R means the distance from one potential to the other potential line. So you are traveling some distance, so that is that R out there. That is the separation between the two potential lines. Okay, cool. All right. Rajshekar, sine 30 is root 3 by 2, is it? Think again, sine 30 is not root 3 by 2, beta. Come on, this is done in 9th and 10th standard. You should know sine 30 is half. Okay, be careful. Okay. Yes, Sujal, please do that. Okay, thank you, Vahi. Let's get going to the next one coming up on your screen. Okay, let's see how many of you are going to get this. This is a difficult one. Yes, Deepak, this is 12th standard syllabus, beta. Yes, and we are preparing for the March attempt. That means obviously you should know 11th and 12th syllabus complete. And if you do not know, at least know the basics. At least some idea should be there. It should not be like, sir, what is potential? Sir, what is potential energy? If you are at that stage, then please join the crash course so that you can study every topic in detail and you can revise all the concepts. Or second option is please go through my playlists out there. Let's see how many of you get this. Wow, JP Lakshmi, you're from Risti G batch. Okay, let's go ahead. Let's get going. Let's get going. Single, don't spam, else you will get blocked. Okay. Well. Let's see how many of you are going to get this. Let's see how many of you are going to get this. Come on, minions. Come on, minions. B, C, B. All right. Now, I'll tell you what. This is again based on this concept. Electric field is negative rate of change of potential, dV by dr. But when both x and y are there, remember I have told you this, the x component will be dV by dx and the y component will be negative dV by dy. So since both x and y are there, so it will be d by dx of kxy. But remember, x is a variable, k and y are constants. So basically it will become minus ky and derivative of x with respect to x, and electric field in the y-axis will be minus k, and you're differentiating with respect to y, so x is a constant, so dy by y. Now dy by y, dx by x, both are 1, so it will become minus ky, and over here it will become minus kx. So what is the total electric field? It's a magnitude. It will be root of ky square plus kx square, correct, using Pythagoras. Ex square plus ey square, root is electric field. Now k will come out and you will have root of x square plus y square. Now guys, if this is x, this is y, and this is the distance from the origin, isn't x square plus y square equal to r square? So that's why this will become k times of r. So that means the electric field is going to be directly proportional to the value of r. As simple as that. Very good. Very good, Utkarsh, Haider. Very good. Yes, x is not equal to y, Abhishek, be careful. All right. And Utkarsh, don't spam. Haider, don't spam, else you might get blocked. So last warning. All right. Make sure that you guys don't spam. Okay. Very good. Very good, Utkarsh, but very good. Okay. So Shruti Bhaskar, please understand whatever doubts or whatever queries you have, please post it in the comment section after the video. Right now I'm going in a flow, I'm teaching all the concepts, I'm solving all the problems, so I might not be able to address your individual doubts regarding percentile or how the plan should be done. All right, so I'll respond to all the queries in the comment section, or second option, ping me on Instagram, Shreyas_Vedantu. That's my Instagram handle. Okay. Yes. Either spam means typing the same thing again and again, or just unnecessarily typing gibberish. Okay, so don't type the same thing. I can read all your comments, all your chats, even if you type it once. All right, cool. Thank you, Abhishek. No problem. Dora, I didn't start gravity yet. We are going to start it in some time. Now, this is a beautiful question. It's not going to be so easy. I'll give you 1 minute to solve it. Let's see how many of you can do this. 1 minute to solve this particular question, guys, and countdown starting now. Okay, okay. Venku, the commentary section will open up after the session is over, not before. During the live session, only chat box is open. All right, only after that it will open. Okay, come on, minions. Come on, come on, come on. Vijalata ma'am, please replay back the session. Definitely you will understand it. All right, that's the advantage of YouTube. You can always replay it back, listen to it again and again. Come on, come on, come on, come on, come on, minions. Come on, come on, come on, come on, minions. Let's see. Within 1 minute, you can get it. It's not so easy. It's going to be one of the toughest questions if it comes in the actual examination. Okay, okay. Almost there. It's almost going to be done. Come on, come on, come on. Let's see how many of you are going to get this. B, D, C. Abhishek, no, I don't have. All right, yes, yes, Aniket, you are there yet. Very good, you figured out. Okay, the correct answer is actually C. Now I'll tell you why the answer is actually C. So first of all, let me go behind and let me show you what has to be done. First of all, assume the charges. Let's say there is a plus Q charge here, then there is a minus Q, then there is a plus Q, and then there is a minus Q. Same thing, minus Q, plus Q, minus Q, and so on and so forth. Let's take this charge as our origin, and from this charge, each of these charges will be at distance A, then 2A, and then 3A, and so on and so forth. Okay, so this is going to continue. Now, understand the question is find the energy of interaction of a charge with the rest of the charges. The charges are there from minus infinity to plus infinity. Okay, now this charge with this charge, all right, so we are calculating the energy, will have an interaction energy of K, but it will be negative. All right, one of the charges is negative Q square by distance of A. Now similarly, another negative, this is a positive charge, so that will be nothing but K Q square, correct? It's a positive charge by 2A. And then again you will have a negative term which is K minus Q square, all right, but that time it will be 3A, and there will be many more terms like that. But whatever answer you get over here, all right, whatever answer you get over here, that's for one side. This with this, this with this, this with this, this with that, till infinity. Same things will be also there by symmetry on the other side. So whatever answer you get over here, multiply it by 2 to get the total energy. So this 2 is because on the left and the right side because of symmetry. All right, now this will be equal to 2 times. Take out the common terms. K is common, Q square is common, even A is common. What is left inside? Minus 1 by 1, all right, plus, okay, 1 by 2 minus 1 by 3. Obviously, the next term will be 1 by 4. Next term will be minus 1 by 5 and so on and so forth. Now, even take the minus sign outside. So, it will become minus 2 and then you will have Q square by A. K is nothing but 1 upon 4 pi epsilon naught. And you will have 1 by 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 till infinite terms. Now let me tell you, this is the expansion of this term. You should know this expansion. ln 1 plus x, log of 1 plus x. This is very, very important. Log of 1 plus x, guys, is nothing but x by 1, all right, minus x square by 2 plus x square by x cube by 3 minus x raised to 4 by 4, like that. There will be infinite terms. Now if you notice over here in this particular expression, the value of x is actually 1 because 1 square, 1 cube, 1 raised to 4, everything is 1 and these denominators are the same over here. So that means this entire thing must be ln 2. So this entire thing over here must be nothing but ln 1 plus 1. So this will be minus 2 q square by 4 pi epsilon naught a. 1 plus 1 is 2. So this should be the answer. Is that clear? Is that clear? Yes, this is very important. Taylor's theorem. Yes, Yash. This is Taylor's theorem from maths. You should know this formula, else you will not get this question. Very good question, beautiful question. The blend of physics and maths is being seen over here. So happy, please write all your queries in the comment section or ping me on Instagram. I'll definitely answer it. Right now we are focusing on the questions. I'm in the flow. I won't be able to answer any of it. Okay, yes, that's why I said it's a very good question and this will be one of the difficult questions of JEE Mains, and those of them who will crack this will also get a good percentile because very few people will crack this question. No problem, happy. Concentrate on the session, don't worry. All right, let's get going. Very good, Sudan. If you are selected to Eklavya, yes, please keep attending those sessions out there. Now, next question. A conducting disk of certain radius is being rotated with an axis with some angular speed. What is the potential difference between the center and the periphery? Very beautiful question. And again, I'll give you 1 minute because it is not so easy like I'm telling you, because I'm giving you some time over here. Come on, let's see how many of you can do this. No, yes, no other method. I mean, if there is any other method, it will again involve some kind of weird mathematics. All right. Log and ln is the same. Ln is used when it is log to the base e. Okay, cool. Let's see how many of you are going to get this. Very good, very good, very good, very good. Let's see. Come on, minions. Hardly few seconds left. A lot of you are saying B or A. Kashish, I'm just fond of it, that's why maybe. Okay, the correct answer is actually B. Now let me tell you how to get to this. See guys, first of all, understand why is there a potential difference. When you rotate anything, what will happen? It will get thrown out, correct? Now when it gets thrown out, what are the things which will be thrown out over here? It's a conductor. So when you rotate a conductor, the electrons, which are the free electrons, will be thrown outwards. So if all the electrons start getting thrown outwards, now what will happen? There will be a positive charge which will be developed. Now these electrons have traveled from inside to outside. Now because of this, what will happen? Any new electron which will try to move outwards will be prevented by the electrostatic force. So what will happen if a new electron tries to move outside? These negative charges will push that electron back, and these positive charges will also pull that electron back. So there will come a point of equilibrium when you will see that on the outside periphery, alright, you will have these negative charges out here, alright, you will have these negative charges out here, and you will also have a positive charge being developed over here, and there will be electric field like this from inside to outside. So there will be an equilibrium which will be achieved after some time. I hope that is fine. I hope this is clear. Now let's take any electron which is at some distance x from the center, at some distance x from the center. So let's see what is it going to face. Well, there are two forces that it is going to experience. One is the centrifugal force, which is outside, and one is the electric force, which is inside. Please remember, although the electric field is outward, remember it's a negative charge, and on a negative charge the force is opposite to the direction of the field. So please understand, at equilibrium, alright, at equilibrium of any electron at distance x from the center, alright, at distance x from the center, the force of the centrifugal force will be balanced by the electric force of attraction. Now what is the centrifugal force? It will be mass of the electron into angular speed into x, m omega square r is x. Next up, over here, what is the electric force? Electric force will be charged into the field. Now just rearrange, you will get the electric field is going to be m omega square by e into x. Correct? Everybody got it till here? F centrifugal force, Anna, this is centrifugal, it's not centrifugal, it's centrifugal. Okay, so pay attention carefully. Okay, now I just told you some time back about a very simple law, and that was dV by dx, the negative of that is nothing but electric field. Didn't I just tell you about it? Field is the negative gradient of potential. That means I can put over here minus dV by dx is equal to m omega square e, and there is x. Now I'm not interested in the minus sign because it's going to give me the actual value of potential difference. I'm here only interested in the magnitude of the potential difference. Okay, so I'm only interested in the magnitude. So don't worry about it. Let's just integrate. So dV with a negative sign is m omega square by e, and x dx. So let's integrate it from both sides. And here I'm going to get nothing but the potential difference. Integration of dV is going to be from 0 to r, right? So this will be m omega square by e, and this will be r square by 2. So where is it? Yes, this is the correct answer. Mass of electron into angular speed square into r square by 2 times of the charge will be the magnitude of the potential difference. I hope this is clear. I hope this is clear. Is this understood? Yes, Sujal will be starting it in some time, maybe around more 15-20 minutes or half an hour. Okay, cool. Is that clear? Very interesting question. Yes, Nia, it's a very awesome, superb question. Kashish, this will be a session for almost 2 hours till 9 o'clock. Let's get going to the next one coming up on your screen. Electric dipole is placed in electric field generated by a point charge. Which of the following option is correct? Only one of them is correct. Let's see how many of you can get this. Draw a charge, show the field, and place a dipole near a charge. Near a point charge, place it. Okay, cool. Come on, guys, let's do this. Come on, minions. Come on. Utkarsh, whatever your doubt was, please post it. Very good, Abhishek. Please post it. Anna, don't spam. Type it only once. I can read it. Okay, don't worry. All right. A lot of you are saying A. Thank you, Devki. Glad to know that. And guys, if you are liking this session, please do not forget to support me by smashing that like button down there And if you are new to this channel, do not forget to hit the subscribe button so that you do not miss any of the live updates and live sessions out here. So yes, go ahead, click on the bell icon and hit the subscribe button right now. Come on, minions. Come on. A lot of you are saying D and A. Priyal saying B. Prav saying D. Chandramoli saying D. Gauri saying amazing teaching. Thank you, Gauri. All right. Hello, Naveen Reddy. Welcome. Amazing. And I'll tell you how this works. See guys, if you take a point charge, the field due to a point charge will be like this, correct? The field due to a point charge will look like this. Okay. Now let's try and analyze it. If you take a dipole, okay, so this is a positive charge, this is a negative charge. First, think about it. This positive charge will get a force this way, and since it is closer, that force will be more, correct? And this negative charge will face attraction and this force will be small. The resultant of this force, because repulsion is more than attraction, will be a repulsion, correct? It will face some net force. So the net force will be there. So will a dipole placed in the field of a point charge experience net zero force? Wrong. The net force may be zero. Well, the net electric force on the dipole may be zero. Yes, that's possible. But right now, at least I cannot see that the net force is zero, because no matter how I orient it, let's say I put the positive charge here, negative charge here, this positive will experience force like this, this negative will experience force like this. Again on this dipole, the net force is not zero. Oh, no matter how I orient it, the net force is not zero. Yes, so option B is wrong. You can see that option B is wrong. Net force on the dipole may be zero. No, in fact, it is never zero. Never zero. Net electric force on the dipole must be zero. Well, the net electric force on the dipole must be zero. You can clearly see it is not zero. It is not zero. I hope this is clear. Yes, it's very important. Well, Yalini, it is not mentioned whether it is uniform or not, but it is mentioned it is filled by a point charge. How does the field because of a point charge look like? In fact, it is non-uniform. In fact, the field distributes everywhere. As you go far away, the field becomes weaker. That is why it is very important. Next thing, the torque on the dipole due to the field must be zero. Well, you can see in this situation there is no torque because the forces are along the same line. So in fact, over here the torque is zero, but here the torque is not zero. So the torque due to the field must be zero. Wrong. This is also wrong. The torque on the dipole due to the field may be zero. Sometimes zero, sometimes not zero. Yes, sometimes zero, sometimes not zero. Hence option D is correct. Understood? Understood? This is a very beautiful question. You need this bit of analysis, and if you got the answer by any other means, that is wrong, and if you are doing it by any other means, that is also wrong, because you cannot use elimination. Please understand, you have to attempt every question conceptually. Let's get going to the next question. Okay, so Aryan, please attend these sessions, because these sessions are meant to make you apply whatever theory you have learned into problems. See, if I just keep teaching theory, it's of no fun, Aryan. That's why we are conducting this session, so that you learn how to use these theorems, how to use the concepts, see how I'm thinking, see how others are responding. That's how you will learn. Okay, so that's why we are conducting these sessions. Next question. There is a given charge which is situated at some distance from a dipole. All right. Now, the force experienced is F, and now if the distance of the charge from the dipole is doubled, then what is the new force going to be? Come on. Rishabh, you can just replay back the same part again. That's the beauty of YouTube. You can just do that, and that will be helpful. Come on, minions. Come on. Okay. Rishabh, just replay it back again. All right. Come on. B, D, Paras saying D, Anita saying B, Golden saying 2F, Ishita saying C, Gravitation is also coming. Wahi, hold on. First this, then flux, Gauss law, and then slowly gravitation. Hold on, hold on, hold on. Come on, minions, let's do this. Okay, well, I'll tell you what the correct answer is. See guys, the field due to dipole, if you remember the formulas correctly, it used to be always some constant, some dipole moment, etc., something, 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 upon x cube or y cube or r cube. This is what is there. Cube is there below. It's inversely proportional to the cube. Please understand, not square. That's the catch. And field is directly proportional to the force. So hence, force is inversely proportional to the distance cube. Now what have you done to the distance? The distance has been doubled. So the cube of the distance will be made 8 times more. So the force will be 8 times less. So correct answer is F by 8. Understood? Very good, Utkarsh, Anita. Now you guys got it. Very good, Kashish, Golden, Abdullah. Yes, 1 by 8. Yes, it's not r square. It's not r square, Abhishek. It is r cube. Okay, it is always r cube. Please replay it back. All right. All the dipole related formulas have, for field it is cube. For potential it is square. Be careful. For potential it is square. For field or force it is cube. Keep this in mind. Okay. Next question. An electrical dipole is placed in somebody else's uniform field. Separation is D, and if you turn that dipole, all right, it will experience a torque. So it will come back, but it will gain some momentum and it will go to the other side. And now it is going to continuously oscillate back and forth like this. All right. The question is, find the angular frequency of oscillation because of the torque which is produced. Their separation is D. Let's see how many of you are going to get it. Come on, come on, come on, come on, come on, come on, minions. Come on, minions. Dance Star, the PDF will be shared on the Telegram group. Akash Dominic, don't spam or else you'll get blocked. Okay, come on, minions. Come on, come on, come on, come on, come on, come on. Very good, Yalni Stored. Excellent. Turkish P Crossy, yes, use that. Use also SHM. Come on. Yes, I agree with you, Sakti. I don't know what relatives do with the results. Titan Gaming, don't spam or else you'll get blocked. Abhishek saying B. Sanjay, if you have not studied 12th, then I don't think you can clear JEE Beta. You have to study 12th. It's not possible because a lot of questions are coming from 12th. So please join the crash course or ping me on Instagram or type your doubt after the video ends in the comment section. Okay, I'll tell you how to do this. Okay, a lot of you are saying B or A. All right, Shruti saying D, I guess. All right. Okay, now see this. Torque is dipole moment cross E, correct? So magnitude wise it is PE sine theta. What is dipole moment? Charge into the distance. Field is field. But for small angles, if theta is small, all right, because it is displaced slightly, sine theta is theta, so the torque will be approximately QD. P is nothing but QD into E into theta. Sine theta is theta, that's a small angle approximation. Now, just like when force is proportional to x, similarly, when torque is proportional to angular displacement, remember one thing guys, whatever is there over here, okay, whatever is there over here, this will become the constant, the force constant, this will become the torque constant. This is like F is Kx, instead of that torque is something into theta. That's the only change, and therefore the angular frequency will become nothing but that constant divided by moment of inertia. Like omega is root of K by M for linear SHM, for angular SHM it is the torque constant by the moment of inertia, which is the equivalent of mass. That's all you need to know, and that's it. Now solve the question. Constant is nothing but Q D E, and what is the moment of inertia? Think about it. Well, this is where it is rotating about. Now the moment of inertia will be M L by 2 Why L by 2? Because this distance is L by 2, even this distance is L by 2. So m L by 2 square plus m L by 2 square. So ml square by 4 plus ml square by 4, that's going to make it ml square by 2. So just put it over here. So you are going to get ml square. Actually, that L is D over here, my bad. So I'll just put it as D. So it is md square by 2. dd goes and 2 goes on the top. So it will become root of 2qe divided by md. So that should be option B, I guess. That should be option B. Thank you, Rishabh, so much. Ravan, gravitation will also come. I'm going systematically. If you have noticed, we started with forces, field, energy. Now we are going to dipole, and now we are slowly going to go to flux, Gauss law, and slowly going to come to gravitation. Hold on, everything will be completed. Have patience. Don't be so, don't be in such a hurry or haste. All right. How do I get that formula for omega? This is a standard formula of SHM, by the way. So you should remember it. So like for linear SHM, all right, time period is 2 pi under root m by k, and omega is root of k by m. So for angular SHM, instead of k, it is torque constant, and instead of mass, it is moment of inertia. Okay. So that d square got cancelled, na beta. This d square got cancelled from here. So you can see that. That's why that d is remaining. Okay, cool. Subbu, please pay attention. It's all there. Thank you, Rishabh, so much. All right, let's go ahead then. So this is the answer for the question, all right, which we just got it. Let's get going to the next one. A cylinder. Now we are coming to Gauss law, flux, etc. A cylinder of radius r, length L is placed in a uniform field parallel to the cylindrical axis. The total flux on the surface of the cylinder is given by. Come on, let's see how many of you are going to get this. Come on, let's see how many of you are going to get this. Very interesting. Thank you, Utkarsh. Ringa, which part you did not understand, please let me know on Instagram, or let me know in the comment section below the video. I'll definitely help you out. Or you can always replay back the session. Okay, come on, come on, come on, come on, come on, minions. Come on, come on, come on, come on, everyone. Let's see how many of you are going to get it. A lot of you are saying A. Abdullah saying A. Gaurav Zagde saying A. Vahi saying D. Ananda saying D. Prerak saying D. Andrew, Ramesh saying A. Velaga saying 0. Well, I'll tell you what. See guys, what is happening is that the electric field is just going to go in and out. E is parallel to the cylinder, so nothing is actually being originated or terminated here. Whatever comes in goes out. Whatever comes in goes out. So whatever comes in goes out. So in is equal to out. That's it. Net flux will be 0. That's it. As simple out. As simple as that. Yes, very good. As simple as that. Understood? Very good. Very good. So golden locks, if you have not studied 11th because of Corona, and if you want to crack JEE next year, yes beta, you can definitely crack it. Just ping whatever doubt you have after the video, not now. Okay, so we are right now focusing on the session. Please post all your doubts and comments below the comment section. All right, once the video is over, you cannot post anything now. Okay, in case of perpendicular also, it will be 0 Shibi, because whatever will come in will go out. Doesn't matter. If number of lines entering and exiting are same, nothing will matter. The answer will be 0. Okay. Ravan, I just mentioned your doubt, so don't ask the same thing again and again. I just told gravitation will come after some time. Come on, let's see the next question. Phi1 and Phi2 are the flux which are entering and leaving a closed surface. Then the net charge inside that closed surface will be. Some of you are saying A, some of you are saying B. Come on, minions. Come on, come on, come on, come on. All right, all right. Okay, come on, Ravan. Come on, Manui Elite says D. RK Singh says A. Baby Bear says A. Ria says B. Come on, minions. Naveen says B. People are confused between A and B. Now, let me tell you guys, I just told you, whenever field comes inside, all right, then that is considered to be negative. And whenever it leaves, that is considered to be positive. What is coming in? Entering is Phi1, so this is negative. What is leaving? That is Phi2, so leaving out is Phi2. Okay, so what will be the net flux? So think about it. the net flux will be nothing but phi 2 minus phi 1. And what is the net flux equal to? It is the enclosed charge which is inside divided by epsilon naught. So what will be the inside charge? This multiplied by epsilon naught. So that should be option A. That's the answer. Correct? Very good. Very good. Yes, Rishabh, all questions, whatever I'm doing are important because this is Zero to Hero series. I'm covering all the concepts which are very likely to come in the examination. So attend each and every question. You never know which of these questions conceptually will get repeated in the March or the April attempt. Let's get going to the next one. Very beautiful question. Let's see how many of you are going to get it. Yes. Thank you, Alaru Jitendra. Well. In a region, electric field depends on the x-axis as E is equal to E naught x square. There is a cube of edge A, alright, hypothetical one. Then find the net charge enclosed. Now, what do I mean by this? E naught x square, that means the field is variable, but the field is only along the x-axis. At this point it is different, at this point it is different, at this point it is different. So my advice to you is first calculate the total flux. There will be certain phases where the flux will not be there only because of some reason. So calculate the total flux and from that try to figure out by Gauss law what is the net charge enclosed. Come on minions. 88FF, welcome to the new class for you. Well, come on, we are doing Zero to Hero series of electrostatics, Gauss law and gravitation. Lot of questions, expected questions for March and April attempt. Join in, and if you guys are new, do not forget to hit the subscribe button and do not forget to smash that like button so that you do not miss on the new videos, new lectures that we are going to conduct. Yes, Ananda, why not? Why can't they be in this manner? Obviously, you can have questions on this. So Varshita, and this is not a CBSE channel, this is a JEE channel, so we will not be doing CBSE related chapters, sorry, not CBSE related questions out here. We are exclusively for JEE and those kind of entrance tests, alright. So JEE and NEET, yes, definitely you can attend these classes, but for CBSE there is a separate channel out there. Okay, come on minions, a lot of you are saying A or C. Hello Sanjay, welcome. Okay, very good Sanjay, you are also a new student. Well, I'll tell you what to do. First of all, the field is going like this. There is no field which is going to intersect this, then also, what is that? This surface, and, oh sorry, not that one, and this bottom surface. So all these surfaces will have no flux piercing them. So the flux through the top, the flux through bottom, the flux through the front, and the flux through the back surface, all of them are zero. Because the field lines are like this, the field lines are only piercing left and right surface. So some lines are piercing here on this surface, and some lines are piercing on this particular surface. So here it is entering in, here it is going out. First of all, what is the field on the left surface? So electric field on the left side will be equal to, use this formula, E naught. What is the value of x? Well, that is 2a. This is given to be 2a. So 2a, all right, whole square. That means it is going to be 4 E naught a square. Now the flux from the left side, because it is entering in, remember entering in means negative, going out means positive. I have just told you this. So that means this should be negative, and flux is field multiplied by area. Remember that. So what is the field? The field is 4 E naught a square. What is the area? The area of that side will be a square. So this is going to be minus 4 E naught a raised to 4. That is the flux on the left side. Similarly, you can figure out what is the flux on the right side. Now on the right side it is exiting out, so it must be positive, and it will be again field over there. What will be the field? Use that formula. It will be E naught into x. X will be careful, it will be 3a. X will be 3a. So 3a whole square multiplied by area. What is the area again? The area of this side will be a square. So this is going to be 9 E naught a raised to 4. Now from these two results, okay, flux from left and flux from the right, you will get net flux, and net flux will be this plus this, which is going to be 5 E naught a raised to 4. And what is net flux always equal to? It is nothing but inside charge by epsilon naught. So just take epsilon naught over there. So where is 5? Here. That's the answer. So Rishabh, just understand the field is varying. At this point the flux is the field is different, and at this point the field is different. Here the field is entering in like this, here the field is exiting out like this. So you have found out the field at the left side and the field on the right side, and this flux will be positive, this flux will be negative. That's by convention. So I just found out the flux on the left side, flux on the right side by multiplying field and area. I know that on the front, top, back and below the flux will be 0. So using Gauss law, net flux must be enclosed charge by epsilon naught. That's it. That's it. That's how it is. How is it 3A, Varshita? Because this is 2A, this is A. This is, I'm not sure if it is visible, but let me tell you that this is given to be, all right, this much is given to be 2A. Okay, maybe it's not so visible, but it is 2A. Cool. Clear? Very good. Very good. Sujal, maybe you can ask it later on, maybe on Instagram or maybe below. Okay. No, Ananda, in will not be equal to out because field is varying. On the left side and right side field is not the same. So whatever is entering is not exiting out. So that's why net charge is not 0. Okay. Clear? Great. Great. Chalo. Let's get going to the next one. Beautiful question. Very important question. These kind of questions can come and it will be a difficult one. Now, satellite. A geostationary satellite is the one which is, come on minions, let's see how many of you are going to get this. Why should we consider the distance between axis and the cube? Gauri Shankar, because of the, the coordinate system for the previous one. Look at that. For the previous one, x-axis is here, this is the origin. So at this point, the cube's left face is already at 2A distance. So you need to account for that. Very good. A lot of you got C. Excellent. Excellent. So Rishabh, contact me on Shreyas_Vedantu, which is my Instagram handle. The link is also mentioned in the description box below. Check it out. Okay. So very good. The answer is C. Excellent. So this was a laddu question. This was an easy question. This was easy peasy lemon squeezy. Let's get going to the next one. Okay. This was just to boost your morale. Come on. Let's see how many of you are going to get this. Very good, minions. Which of the following graph represents the motion of a satellite revolving around a planet? T is period and R is the radius of the orbit. Come on, minions. T square versus R cube, T versus R, T versus R, T square versus R cube. Let's see. Come on, Sanjay says A, MSG2 says C. Come on, minions. A lot of you are saying A. Very good. Let's see. I don't know. Krishna saying C. Keshav saying C. Others saying A. Well, Utkarsh saying C. Naveen saying D. Well, guess what, guys? This is based on Kepler's third law. The correct answer is actually A. Remember, Kepler's third law says T square is directly proportional to R cube. This is third law of Kepler. That's it. Law of time periods. If you know that, you will get it. So if it is directly proportional, it should start from the origin and it should be a straight line. In this graph, you can see there is some gap over here. This is not correct. And these two obviously are incorrect. So hence correct answer is A. Okay, let's get going to the next one. Now this one is a little bit tricky. Let's see how many of you are going to get it. Okay, come on, come on. I hope Keshav you understood it. Yes, Sriswat Mishra. I hope you understood why it is not B, because it is not passing through the origin. That's very important. Venko, because I have been teaching for almost 10 years now, and you can also remember all the concepts if you practice. So if I stop teaching, let's say for 1-2 years, I will forget. Understand? Because constantly staying in touch is very important. If I don't stay in touch, I won't remember it. So that's why for you guys also, it's very important that you keep revising all these chapters. So attend these live classes so that you will never forget. I touch upon so many concepts in these chapters. So definitely you are going to remember it. Yes. Well, no, Manu Elite. We are going to ignore that. It's going to be constant for some extent. No. I'm guessing you are taking into account the radius of the planet or something. No, ignore that. The graph mathematically will pass through the origin. That's what is important. It will not pass outside the origin. It has to pass through the origin mathematically. That's what is important. Mohammad Rafiq, no, I'm not a first bencher and I like your name. Reminds me of this singer. Okay. How do you know whether it is proportional, Rushabh? That's because of the theory. So if you know the theory well, then obviously you remember that it is proportional. That's it. Okay. That's Kepler's third law. Okay. So let's get going. Yeah, the class is going to be till 9 o'clock. Well, I'll tell you what, guys. I'll tell you how to solve this problem. The escape velocity normally for the surface of a planet is root 2 gm by r. This is the standard result, okay, for surface. But if you have a point mass at the center of a planet of mass m and radius r, and you want to throw it with some velocity so that it escapes till infinity, then you need to derive this answer. You will not get it otherwise. So what you need to do is potential energy at the center plus kinetic energy at the center will be equal to potential energy at infinity plus kinetic energy at infinity. What is this? This is nothing but energy conservation, nothing else. It's nothing but energy conservation. Now, what is the potential energy at the center? Now, that is something which you should know. Let me remind you of that formula. The potential energy general formula for a solid sphere is minus gmm by 2 r cube into 3r square minus small r square. This is the formula. This is something you should remember. In fact, I just gave it to you at the start of the class. So in case you have forgotten, please remember the same formula is also there for uniformly charged solid sphere. So instead of G, you will get 1 upon 4 pi epsilon naught. Be careful. Is that clear? So for gravity, there is minus G. For electrostatics, it is 1 upon 4 pi epsilon naught. That's the only difference. But other things are same. Now at the center, all right, R is equal to 0 at center. So what will you get? What will you get? Think about it. You will get 3r square by 2r cube. R square and r cube will get cancelled. One of the r will remain. So you will get minus 3 by 2 gmm by r. Keep this in mind. Gmm by r. So 3 by 2, small r square is gone out there. Yes. Now, kinetic energy at the center, it is half mv square. Potential energy at infinity, 0. Kinetic energy at infinity, you throw it so that after it goes really far away at infinity, it almost stops. So this is how you will do it. Now, just rearrange. So you are going to get, by the way, this small m and this small m will get cancelled, and that's why you're going to get v square. Oh, this 2 also will get cancelled. So I can just cancel this 2 also over here, and I will get v square is equal to 3gm by r. Check this out, 3gm by r. Now from here, think about it. If I square it, I'll get escape velocity square is 2gm by r. Correct? If I square it, I'll get escape velocity is 2gm by r. That means I can use that over here. Gm by r is nothing but ve square by 2, that is v square. So naturally from this, v is escape velocity into root of 3 by 2. 3 by 2, root 3 by 2. Yes, this is the answer. Is that clear? Yes, Saluru, correct. In fact, I have done formula sessions for electrostatics and gravitation before this. Please check out the past videos. Guys, I feel so bad. You know why I feel bad? Because when I was there, when I was studying for my 11th and 12th for JEE, there are no YouTube channels. YouTube was not so popular, and even if YouTube was there, I mean, there are not many videos on that, not many teachers teaching online, and plus teachers teaching in English was not at all there. And there was no online education at that time. Forget just YouTube. Even there, if I had to sit at home and study, because I wanted to save on travel, I wanted to save on timing, I wanted that flexibility of teachers, I wanted to sit at home and choose my own schedule and plan everything. That was all not there. And you guys all have that kind of facilities. You guys have everything on this channel, and you guys are not utilizing it. You guys are not publicizing it. You guys are not telling it to your friends. Hey, why? If you see your friend not doing well, you should tell him, hey, you do not know gravitation? Sir already has made a lecture series on gravitation. Oh, you do not know capacitors? Don't worry, there is already a lecture. Or even if you do not know, okay, sir, I don't know magnetism. Guys, there is a lecture there on magnetism on this channel, in this playlist. Please go check it out. Learn everything. Do not expect everything can be learned in 1 hour. Guys, do you think cracking JEE is so simple? No, right? Do you think everything can be done in the last 1 minute? No, right? So understand, you need to give that time. You need to justify that percentile. Nobody, if somebody is telling you you can get 99 percentile in just attending 5 classes, guys, they are lying. Please understand, it's not possible. And we do not do that in this channel. Like, we do not base our lectures, or we do not publicize, or we do not promote, or we do not tell you false things which are not possible. We only tell you things which are possible. So guys, understand that you need to put in that hard work. You need to dedicate that much practice. There is some basic amount of practice, basic amount of knowledge which is required to get a certain percentile. Nobody in this world can give you a high percentile in a short duration, which could be like 1 day or 1 hour. Not possible. You need to study regularly, dedicatedly for a lot of time to get a good rank. That's the only way, the gateway to success. Keep this in mind. All right. So let's get going to the next one. All right, coming up on your screen. Glad to see so many of you out here. Yes, coming up. Okay, here is the next one. Come on, thank you, Arshita. Yes, baby bear, I'm glad that you are really happy out there. Come on, Keshav, this class is going to be till 9 o'clock at least. Yeah. Let's go to the next one. Let's see how many of you are going to get it. Come on, minions. Glad Nancy you found it. I know it's very difficult to find this channel if you do not know about it. I mean, you have to specifically search for JEE English, then it will pop out, and but somewhere in the results. But you should definitely tell it to your friends that please go ahead, join this channel so that you do not miss on the learnings out here. Come on, come on, come on. Let's see. Thank you, Manu. All right. No, Mohammed, I'm not trying to give you any fear about JEE. I'm telling you the facts. Because there is no point in telling you, hey, you know what, just attend my lecture for 1 hour and that's it. I'll make you clear. A lot of people do that. You can clear and you will get more than 200 plus just by attending 1 week of classes. Not possible. Now, how is it possible? Just in 1 week, you can get 200 plus. So what about the others who are studying for 2 years? Are they fools or are they donkeys? Like, they're studying for 2 years and they're not, they're still trying hard to get that. So understand, you need to dedicate extra effort in the last few days so that you can boost your performance. So understand that. Yes. No problem, Devki. Now that you know it, please attend it regularly. So let's see how to solve this. Yes, let's do this. Good evening, Kushali. Welcome. Join in a little bit late, but it's okay. Okay, the answer is here, but still. Acha. So the force will be mass into centripetal acceleration because it is going in a circular path. So let's do this. The force is proportional to r raised to minus 5 by 2. That means some constant, I don't know what, into r raised to minus 5 by 2 is equal to m omega square r. Now bring that r over there. It will become k into r raised to minus 7 by 2. This will become r raised to minus 1. In case you did not realize it, no problem. This will become r raised to minus 1 is equal to m omega square. So this will become k into r raised to minus 7 by 2 is m omega square. Now omega square means it is 2 pi by t whole square. Now you can check this out. This will become k by r raised to 7 by 2 is m 4 pi square by t square. Now guys, isn't it obvious from here that time square, because k, m, 4 pi are constants, so time square is proportional to r raised to 7 by 2. So that should be the answer. Time square is proportional to t square is proportional to r raised to 7 by 2. Is that clear? Well, Sandesh, if you are JEE 22, yes, you can definitely attend. But remember, you should know electrostatics, because there are some questions of electrostatics and Gauss law. But gravitation is a 11th standard topic, so definitely you can attend. Very good. Definitely, Rishabh, why not? 97.5 and 99 are close by. Definitely you can aim for 99 percentile for April attempt. Why not? And maybe just by removing your silly mistakes, conceptual mistakes, Rishabh, 1 percentile will increase because of that only. And the remaining 1.5 percentile will just increase probably because of your hard work, your dedication, your effort, and your focus. Okay. Now, before going to the last few questions, are you guys ready for the most good questions, or I would say the best questions, the most exciting questions of today? Are you guys ready? Are you guys ready? Yeah. No, Sakti, you cannot use Kepler's law, because Kepler's law is valid only when gravitational force is proportional to or inversely proportional to r square. In the previous problem, it was proportional to minus 5 by 2. So you cannot use Kepler's law in the previous question. Is that clear? Okay, let's do this. So Preksha, if you have got 94, getting 99 immediately is a little bit difficult, but till May you can achieve it. Till May you can somehow push yourself and achieve it. Why not? Yeah, but you need to put in a lot of effort. You need to study more than 12 hours every day. Then only it is achievable. Otherwise it is not possible. Let me tell you that. Okay, now those of you who want to cover a lot of things in this duration of few weeks, and who want all the topics to be revised in live classes, we have an option for you. Let me tell you, and that is basically the crash course. We have a dedicated crash course for all the 12th and the dropper students who want to cover all the topics in the next 3 weeks, so that they can utilize this crash course concepts, this revision, these notes, these assignments for the April as well as the May attempt. So guys, if you have 90 percentile, 94 percentile, 93 percentile, 97 percentile, and if you feel that you want to do much better, you want to boost up your percentile, and you will see a lot of difference in this crash course, because there will be mock tests, there will be doubt solving, there will be regular sessions, there will be all the subjects which will be covering all the 11th and the 12th standard topics with the best teachers. So guys, this crash course can be also viewed in replay mode. So if you feel like revising a topic again and again, you can watch the replays. And also let me tell you, the doubt solving will happen from morning till night, along with mock tests every week, with analysis and with discussion, which a lot of institutes do not do. So all of this for 10,000 without the coupon code. With the coupon code SHCC, you get the crash course, which is for 7,000 rupees. It's hardly 50 rupees per lecture or something. So if you calculate the cost, 50 rupees per session or 60 rupees per session, that's it. So do not forget to check the link which is there in the description. Join it today, because the batches will start every Monday, and please do not miss on this opportunity, because the later you join, the crash course will end later, the lesser time you have for preparation. So please join it as early as possible, which is very important. Okay, DJ Rocks, you just spoke my mind. I'm keeping a LCR circuit lecture on or after the March attempt. Okay, so after the March attempt discussions, definitely I'm keeping LCR circuits. Okay, so think of it this way, Shruti. Teachers just like me are teaching, or in fact much better than me, because I know these teachers very well, all the 3 teachers. So guys, let me tell you, these batches are also there in English as well as Hindi. Yeah, there is an English batch, there is a Hindi English batch. So you can enroll yourself in the English batch. Once the batch starts, or once you are enrolled, just you will get a call, you will get an email, you will get a message, everything. Just tell them that you want an English batch. That's it. You are done. You will get into an English batch. Okay. So don't worry about it. So focus on this question now. Let's see how many of you are going to get this. This is beautiful, beautiful 3 questions. Last 3 questions for you. Let's see how many of you are going to get it. Last 3 questions for you guys. Come on. Let's see how many of you can do this. So there is a sphere, it was charged with Q, outside shell was not charged. Now you put a charge of minus 3q on the outer shell. What will be the new potential difference if the old potential difference was V? Come on, let's see how many of you are going to do this. Come on, minions. Come on, Malvika. No, the class is not yet over. Last 3-4 questions are there. Come on. Abhimanyu, all the topics in detail are there in the playlist beta. So please watch the topics in detail, because remember, in 3 hours, nobody, if somebody is telling you that they are covering entire electrostatics in 3 hours, they are lying. It is not possible. I'm telling you that. So what we do over here, we brush up on the concepts. We make sure that if you have even basic, slight idea, through problems will make you understand those concepts. That's what this Zero to Hero series is made for. Okay, Abhimanyu? Cool. Let's get going. Wow, very good, Jagdish. Don't worry. Anyways, you are concentrating on NEET, so focus on NEET now. Okay, well, a lot of you are saying 2V. This is an integer type of question. You can think of it that way. And the question will be like, how many times is the potential going to be? Well, I'll tell you what. Before, how will the charges distribution look like? If there is a positive charge here, there will be negative charge here, correct? There will be negative charge here, induced. And how much will it be? Minus Q, correct? It is going to be minus Q. And by charge conservation, well, there will be a positive charge on the outside. And how much will it be? Correct? It's going to be plus Q, correct? It's going to be plus Q. This is before. Now, when you put a charge of minus 3Q on the outer shell, then what is going to happen is that this inner charges will still remain the same. Why will it remain the same? Because opposite charges should be, or on the opposite surfaces, the charges should be equal in magnitude, but opposite in sign. So you will still have minus Q on the inside, and on the outside, you will have more positive charge. Or what? Oh, wait. The total charge should be minus 3Q, right? Okay, so I need to be a little bit careful here. So there will be minus 2Q on the outside. Yes, afterwards, you will have, so this is after, the red one is after, you will have minus 2Q to keep the total minus 3Q. Minus Q minus 2Q is minus 3Q. Now my point is, if you talk about the field before between these two surfaces, from positive to negative, it will be because of this charge over here ending on this negative charges here. When you add that another charge, don't you see the field lines will still be the same, because the charges here and here are the same, on this surface and this surface are the same. So won't the number of field lines be the same? Think about it. So isn't the field between the conductors before and after the same? And field is the same, that means delta V by delta R is same. This is same, and since delta R is the distance between them, that didn't change. So shouldn't delta V also remain the same? What does it mean? The potential difference remains as before, and hence the answer is V. Correct. I hope this is clear. All right. So if a charge of minus 3Q is given to it, I hope this is clear. Yes, that is the answer. Jyotsna, be careful. Shell charge, net charge is not minus 2Q. Net charge is minus 3Q. Net charge is not minus 2Q. Be careful, Jyotsna. Net charge is minus 3Q. Minus 3Q is given to the shell. Okay, yes, the answer is V. Very good. The correct answer is V. Let's go to the next one. Okay, get ready, guys. Here comes the next question. Now I'll tell you what, I'll try to do this question. Forget reading this question. I'll tell you what is asked. The question is, find the charge distribution and find the field here, here and here. Okay, so 4 questions are there. What is the charges on all the surfaces? And next question is find the field here, here and here. Let's do this. There is a very simple trick which I told you. The trick is, first add all the charges on the plates which is given to you. What are the charges? Q and 0. 0 plus Q, total is how much? Total is Q. Oops, total is Q. Now whatever total charge you get, divide it equally on the outermost surfaces. So you will have q by 2 here and q by 2 here. That's how you can solve this problem very easily. And now just use charge conservation. If q by 2 is here, to preserve the total charge, q by 2 should be here. And to preserve zero charge, minus q by 2 should be here. That's it. This is the final charge distribution. As simple as that. This is the oral method of solving the problems. Is that clear? Great. Next, Keshav, I start all my classes at 7 o'clock beta. That is my standard time. 7 o'clock you will find me here every day. Now, the next thing is find the field to the left of the plates here. Now to do that, there is a very simple trick, and the trick is combine all the plates into one. Combine all the plates into one. It will look like one single plate of charge q. Yes, one single plate of charge q. That's it. So combine all of them together. All right, and there will be field here and field here. So the field on the left and the field on the right side will be the same, and I just gave you the formula, right? What was it? Sigma by 2 epsilon naught. Wasn't it? Sigma by 2 epsilon naught. I just gave it to you. And what is sigma? Sigma is charge per unit area. So q by a into 2 epsilon naught. That is the answer, guys. Is that clear? No, Varun, be careful. It is 2 epsilon. Aha, sigma is q by a. Very good, very good. Excellent, minions. Very good. So now that you have got this, the only thing remaining is what is the field here? What is the field in between? Now, for this point, treat this like one single plate. Treat this thing as one single plate, and because of that, the field will be here. Because of this q charge, all right, q by 2 together, put it. So the field will be towards this side. This negative and this positive on the right plate will effectively be 0. So there will be no net field because of the right plate. Be careful. So the field here, so the field over here will be only because of this guy, and that will be very simple. It is going to be nothing but sigma by again 2 epsilon naught, because remember, because of this plate, the field will be going both ways. So it will be nothing but q by 2a epsilon naught, but this is towards the right side. That's it. That's clear. Is that understood? Is that understood? Why that is 0? The manual guy. See, because of this negative charge, it will be attractive. Because of this positive charge, it will be repulsive. Both of them will cancel each other. That's why, because of the right plate, just check the net charge. What is the net charge? 0, right? So just treat it like one plate of 0 charge. That's why. Okay? I hope this is clear. Very good. Very good. Understood? Understood how to solve this problem? I hope all the concepts are getting very, very clear. So Mohammed, I believe you should start from the basics beta. So I have done the basics of this. Again, please go back to the playlist and watch it again from before. Okay? So I'll repeat over here. I'll see. See guys, if you have one plate which is charged positively of q, the field on either side, all right, the field I just told you, it is nothing but sigma by 2 epsilon naught. And what is sigma? Sigma is charge by area, right? So 2a epsilon naught will be the denominator. So sigma is q by a. That's it. Now understand, if you are here, because of this plate, the field will be here as well as here. Correct? The field will be here as well as here. So at this point, the field will be only this much because of this plate. This plate has no net charge. I hope that is clear. I hope that is clear. Okay. Now, when you want to find the field here or here, just forget these two are separate plates. Just treat them like one single plate of charge q. Now, do you see the field will be here and here? Now, isn't it simple? It's again similar. It will be again q by 2a epsilon naught. One field will be here, one field will be that side. That's it. I hope this is clear. I hope now it is fine. Muhammad, Harsha and others. All right. I hope this is clear. Okay. Thank you, Siddharth. I love you too. Okay. So all these answers are mentioned. Okay. Now Last question for today. Last question for today. Come on, minions. Let's see how many of you are going to get this. Last question for today. Now, field is minus bx plus a. That is given. Last question for today. Minus bx plus a. This is the field which is given in a region parallel to the x-axis. A charged particle is having q, mass m, is released from the origin. It will accelerate, decelerate and stop. It stops somewhere. When it stops, find the acceleration at that instant. Let's see how to do this. Let's see how to do this. Okay. Now, for doing this, there is a very simple way. I'll tell you what. Field is given. From field, force will be the charge. What is the charge? Q into field. That means the force will be minus Q B X plus Q into A. Now the moment you see this, yes Sakti, correct, you have to use the force. This reminds me of SHM. I'll tell you how. Try to recollect SHM. Force is minus kx plus some constant. Do you remember that constant force is irrelevant? Like you take a spring mass system, horizontally it oscillates, but you make it vertical, it will still oscillate. mg is the constant force. That constant force has nothing to do with, time period. It does not change the time period. It will only shift the spring mass oscillation downwards. If the mass was oscillating like this, all right, so when you tilt the system, mg is going to pull that system downwards, so it is going to shift the mean position. Correct? I hope this is clear. Now, if the mean position is going to change and you can compare it to this, now this makes sense that when I left the mass from the origin on that x-axis, so look at this. This was the origin, this was the x-axis, the mass was left over here, the velocity was 0, the mean position will be somewhere here, and the next extreme position will be here. I hope you understand this is extreme and this is also extreme. This is amplitude. This is the amplitude. I hope this is clear. This is mean to mean, mean to extreme. That is nothing but the amplitude of the oscillation. Now, can I find the mean position? Yes, why not? What is so special about the mean position? At mean position, the force is 0. The force is 0. Remember that? At mean position, the force is 0. Now, if force is 0 at the mean position, think about it, what we can do. So, at mean position, I can say 0 is equal to minus QB x naught. I'm trying to find what is this x naught value. QB x naught plus QA. Rearrange, by the way, this Q and this Q will get cancelled. So x naught will be nothing but A divided by B. So that is x naught, which is also nothing but this amplitude. So guys, think about it. What will be the extreme position? If this is amplitude, this much distance is x naught, how much will be xe? Think about it. How much will be xe? Think about it. xe will be twice of x naught, isn't it? xe will be twice of x naught. I hope this is clear. So it will be nothing but 2a divided by b. Would it be just 2a divided by b? All right. Now, Jaya, even if you are in 11th standard, you can understand this. This is a 11th standard concept. Yes, now comes the interesting part. Okay, now let's substitute xe value in the force. Where is it? Here. Let's substitute it over here and see what do we get. I'm just going to remove this. I don't need it anymore. Okay, I don't need it anymore. So let's see what do I get. So the force at the extreme situation will be minus q b xe plus aq. So xe's value I'll put it here. So minus q b xe. xe is 2a by b plus aq. b cancels. Minus 2qa plus aq will become minus aq. So that is the force at the extreme situation. acceleration will be extreme force divided by mass. So it is minus AQ divided by mass. And that should be the answer. That should be the answer. Anjali, you have come almost at the last question. Well, I hope this is clear. I hope this is clear. Everybody understood this? How this problem was solved using the logic of SHM? Very beautiful question. Abhimanyu, for school exam, well, conceptually, yes. But for school exam, you should practice more of those derivations and the theory definitions and all that, because in school, they will ask more of that. But from problem point of view, understanding point of view, yes, definitely. Okay. So beautiful question out there. So that's it for today, guys. Well, I hope you enjoyed today's class out there. Okay. And I'll be seeing you again tomorrow at 7 o'clock in another marathon session of, yes, tomorrow, magnetism and EMI. That's what I'll be doing tomorrow at 7 o'clock to 9 o'clock. So do not forget to attend it tomorrow. And if you have missed any of the classes, please watch the replay. That's my humble request out there. All right. Thank you, guys. Take care. And if you want any question to be answered, please post it in the comment section below or ping me on my Instagram handle, Shreyas_Vedantu. I'll be more than happy to help you. All right. Bye-bye. Good night. Take care. Yes, A is the acceleration. Have a great time ahead. Shimon sir will be coming at 9:30. So attend his class after this. Bye-bye.